So how do you validate a causal DAG in practice when you don't have domain experts available? So I have a few thoughts about this, but maybe you could start off and tell us what you
Mhm.
think.
Yeah, so it's definitely a complex question. So I think here, if you don't have domain experts available, the best you have will be typically generative AI, or you also have, it depends the question again, but maybe let me try to give different context. Um, you also have like more and more knowledge graph that are built from scientific literature. So basically, you have different researchers who take tons, thousands of published papers quantifying causal links, and then they try to build these graphs, allowing you to have a quite reliable set of graph with some uncertainty, of course, suggesting causal pathway. But the thing is, you'll see very quickly that when you want to try to the thing is with graph, and let me add this very important thing, you're all it's hard to be really certain about something, and the thing is usually you will start, the main thing is to control for what we call confounders, which has common causes. And the thing is, the further you go down the list of potential confounders, probably the higher, the more uncertain you are. And the thing is, if you make one mistake, it can completely mess up the estimation. If, for example, you include something that should not be included, like a mediator or a collider again. So sometimes it's a matter of focusing on what you're certain, and you stop when you enter the risky zone. Basically, it's this 10th potential confounder, and you're uncertain if you should include it. But at the same time, if you include it, you might also create more issues. That's solving some issues, and this is definitely a complex one. You have to support your domain knowledge, or the lack of here, and this process. You do have data-driven ways. So there is this entire field called causal discovery. The goal is you feed in data, and it tries to uncover the graph based on some relatively more or less strong assumptions. This again will, I would say, in practice, domain knowledge, if you have it, always dominate. So for example, if you see something that's revealed with the data with causal discovery that really goes against what you know, and you have hard proof and long history, usually domain knowledge will dominate. Um, but if it's lacking, this is definitely an interesting tool. Of course, in practice, that's not that trivial. You can look at the book of Alexander Molak. You can probably contact him to discuss more about causal discovery. Martin Huber have also a very good paper. It's called Introduction to Causal Discovery. It's available on Archive. It's a good first read for causal discovery. Last comment on this is, for example, if you use panel data, things that are moving over time with different observation over time for different individuals, it's becoming way more complex already. And in the vast majority of situations, I work with panel data, so that's why it's in practice way harder to actually implement in my settings causal discoveries. So, and Justin, you wanted to add
Yeah, I mean, I think this shows also the different areas where we tend to work in, right? Because in business, right, things move very fast. You know, like sometimes you're lacking this domain knowledge of a certain process, and in business also the system you're studying to understand the cause and effect relationships is can be typically shifting over time, right? How consumers behave, how they react to new features, or how they react to sales, or how they react to marketing efforts. This is something that changes over time, right? Pretty quickly. So I think there we need to be creative and try to piece together these tools like you mentioned, right? We can use LLMs, we can use causal discovery, we can use a whole bunch of tools, knowledge graphs to help us fill in these blanks. I think in the areas where I tend to work is we have more of the domain knowledge, and the difficulty is in extracting it accurately. And I think the point you make about trying to limit yourself when you're starting to enter the gray zone of I don't know what is the causal relationships of these of a particular variable in my system, should I include it in my models, etc. I think also one tool that is interesting is to do like a sensitivity analysis for hidden confounding, which is not super complicated, given that we have packages to do that. And this can tell you how much of confounding you would need to completely eliminate your effect, or other sorts of sensitivity to assumptions that can be quantified. So
Yeah, on this, I really recommend the latest framework by Carlos Cinelli, ASLET, Making Sense of Sensitivity. It's a beautiful way and a very accessible way with simple metrics to do sensitivity analysis. So again, it's called Making Sense of Sensitivity.
thanks for sharing that. I had it on my list. I didn't read it yet, but now that you recommend it,
No, it's amazing. It's really groundbreaking, in my opinion.
okay, thank you.